All right, so yesterday we were talking about conditional probability. That is, oh, no. This is Venn diagram. I'm sorry. This is a Venn diagram. We haven't run that conditional yet, so got my classes mixed up. Okay, so here we go. We got one more Venn diagram problem to do, and it's going to be another big one, it looks like. So we've got 68 seniors, and they are either liking green or purple or yellow. Okay. Now, 43 of them like green. Now again, I think we talked about this yesterday, but if we didn't, let me talk about it again. When you say 43 like green, don't put the 43 here, because this spot represents only green. And these 43 are that entire circle. All right, is everybody with me on that? So that 43 has no place in this diagram yet. All right. 23 said they liked purple. And 32 said they liked yellow. So those are the totals for the entire circles. None of those numbers is going into the diagram. 6 liked all 3. That is going in the diagram because that area, there is a specific area in the diagram that represents all 3. 11 liked only yellow, so this region right here is the only yellows. 15 liked only green, and 4 liked only purple. All right, so here we go. We got to complete our diagram. So, I guess we'll call these things X, Y, and Z like we did yesterday. I don't know what those are. But I do know that the entire green circle is 43. So 21 plus X plus Y is 43. This entire circle adds up to 43. And this entire circle, which would be 10 plus X plus Z, that adds up to 23. That's the purple circle. And 17 plus Y plus Z adds up to 32. All right, is everybody with me? There's my system of equations. Is that okay? All right. Let's simplify those equations a little bit. So that one is going to be X plus Y equals 22. Watch my arithmetic. And X plus Z equals 13. And Y plus Z equals 15. All right, now, every time we do one of these, this is what your system of equations looks like. So it's just really easy to do a little quick elimination. So if I multiply this one by a negative and add these together, then I have Y minus Z equals 9. Is everybody following that? And I already have another equation that says Y plus Z equals 15. So now I can add those. And it looks like Y is 12. And then once I know that Y is 12, I can figure out that Z is 3, if Y is 12. And if Y is 12, then X must be 10. Just by plugging in my 12 into my y's. So then I can come back over here and I can fix these. Let's see, y was 12, z is 3, and x is 10. All right, how many people do I have in there all together? How many people is all that all together? I think it's 61. Anybody else get that? So if there's 61 in here, there must be 7 people out here that don't like any of those colors. So now we're ready, we can answer whatever question we're asked. What question are we asked? If one student is chosen at random, what is the probability that he will like at least one color? What do you think?
Is it 61 over 68?
It is 61 over 68. Because these 61 people like something, right? So 61 people like something, 68 total. There's your probability. I don't think that reduces, so that's it. All right, we okay with that? All right. Let's take a look at the next ones. These are more Venn diagram problems, and they use some different notation, but they're easy. Nothing challenging about them. So here you go. We've got A and B, so event A and event B. So if it helps you, think of that as like, these are the people that like apples, and these are the people that like bananas. Okay, these are just two events, two activities, A and B. Now, we know that the probability of A is 0.6. So this notation means the probability of A. Just like before, that 0.6 has no place in this diagram, because that 0.6 is right here, that entire circle. That entire circle is 60% of the people. 60% of the people like apples. 50% of the people like bananas. But again, that does not go in the picture because that's this whole circle. This is the part you put in the circle. Remember, the upside down U is the intersection symbol. It means and. So the probability that you like apples and bananas is 0.2. That can go in the picture because where are the people that like apples and bananas? Right here. So we put a 0.2 right there. Now, just like before, if the entire apple circle is 0.6, then what does this part right here have to be? 0.4? And if the entire banana circle is 0.5, this has to be 0.3? Now, what do those circles add up to? 0.9?
0.9.
Yeah, so that means that 90% of the people are right here. So who's out here? The other 10% out here. Unlike the last problems we did where we had a class of 68, so everything had to add up to 68, when you're doing it with probabilities, everything has to add up to 100% or 1. All right, so now we can answer the questions. Here are the questions. Now, remember, this means and. This little guy means not. So this means, what's the probability you like apples, but not bananas? So look at your picture. The people who like apples but don't like bananas are right here, aren't they? So that's 0.4. What's the probability of not apples and bananas? So these guys like bananas but not apples. So that's 0.3. This means you are in the B ball, but you are not in the A ball. So that's 0.3. And what does this last one mean? Neither.
I don't like either.
You don't like any of it, that's right. So that says I don't like apples and I don't like bananas. So I'm a 0.1. Yep, I'm a 0.1.
This one, where'd you get the 0.1 from?
Probabilities have to add up to 1. So if this is 90%, 0.9, then there has to be an extra 10%. All right, now the next one is exactly the same thing. Different numbers, but everything's exactly the same. So take a minute and see how much you can fill in of the Venn diagram and then answer the questions.
Is problem B for number 8, how many like both apples
Oh,
and bananas?
shoot, I skipped it. Oh, crap. All right, yes, let me look at it. Let's look at that. We got to talk about that one. That's a little bit different. I didn't even see it sitting over there. Okay, so let me see. So I have 0.4, 0.2, 0.3. Is that right? Is that what I have? Okay. So what this means, I'm sorry guys, I didn't see this problem over there. So what this means is, what is the probability of A given B? That's what this bar means, given. So that means that given you like bananas, what is the probability that you also like apples? Now, there's a little formula for that. Some of you, Tyler's working on it intuitively. There's a little formula for this that you probably should remember. This is calculated by taking the probability of A and B and dividing it by the probability of B. So given that you like bananas, that's your total, the total people who like bananas, what is the probability that you also like apples? So anytime you have this set up, this is going to be the way you calculate it. So what's the probability I like bananas? Isn't
0.9
bananas
divided by
50?
0.3.
Yeah, bananas is 50. The answer is going to be 40. Yeah. So the denominator is 50% because that's the probability of bananas. And then what's the probability of liking both? 0.2. So your answer is 2/5 or 40% if you prefer to write it as a decimal, or 40%. So if you can figure that out intuitively, that is awesome. Tyler figured that out all by himself right away. If you struggle with that a little bit, you can always use the formula to get the answer. So this means, what's the probability that if you like bananas, given that you like bananas, what's the probability you also like apples? All right, thank you. Okay, now let's move on to the next one. And we're going to answer exactly the same kinds of questions, one just like that too, only the numbers are a little bit different. So take a minute and see if you can get your Venn diagram filled in. in the problems, those are supposed to be D's, not B's. Sorry about that. Okay, so are you get your Venn filled in, your Venn diagram filled in?
Yeah.
Okay, what do you have here?
0.4,
And what do you have here?
0.35,
And here?
0.05,
And out here?
0.2.
Now, does there have to be something out here? No, it's possible that all that would add up to 100%, and then you just would have nothing out here. But ours don't. That's what we got. Anybody have a question about that? Everybody's got them? Okay. So now we're ready to answer some questions. This says, this time let's have cookies and donuts. What's the probability I like cookies but not donuts? 0.40, yep, or 0.4. How about I like donuts but not cookies? 0.05. How about I don't like either one? 0.20. Now, this means what's the probability that I like donuts given that I like cookies? So this is the probability of D and C over the probability of C. So given that I like cookies, which is 0.75, what's the probability that I also like donuts? That would be 0.35. Now we need to reduce that. So that would be 35 over 75, which is 5 goes into there, 7/15. I don't know what decimal that is, 7/15. Everybody okay with that? Okay. All right, then the next thing we need to talk about, the very last kind of probability we're going to discuss is called conditional probability. And I think if you read this first question here, you'll understand what I mean. So read number 10A. And this is called conditional probability because doesn't the probability of his doing homework depend on the weather? So the probability of his doing homework is conditional on the weather. Probably the best strategy for doing this, and remember the beauty of mathematics is that you can do everything in lots of different ways. Probably the best strategy for this is to build a tree diagram. So you've probably seen a tree diagram before. So the first branch of the tree is the one that the other one depends on. So homework depends on the weather. So this first branch is going to be rain or not rain. And they're always complements of each other. It's always yes, no. So go, don't go. Happy, not happy. And then the next branch that comes out of that, and again, tree diagrams build on each other, will be homework or no homework. Now, the kids in the room at least recognized immediately that homework was dependent on the weather. for those of you that are struggling with that and thinking, how do I know where to put, I might mix these up or whatever. Whatever the question that's ultimately asked. So whatever question is ultimately asked is always the bottom of the tree, the end of the tree. So in this case, the homework, or the problem that's asked is, find the probability of doing homework. So homework is on the bottom. So if you can't see it in the problem or can't process it, that's one quick way to know always what order to go in, at least when there's two branches. All right, so now I'm going to fill in some probabilities. So some of these, I'm going to put some numbers on all of these little branches here. So if it rains tomorrow, the probability that he'll do his homework is 40%. So on the homework piece, coming out of the rain piece, I'm going to put 40%. If it doesn't rain, the probability of his doing homework is 10%. The probability of rain is 30%. So take a look at those numbers. Those are the numbers in the problem. Take a look at them. And are you okay with all those? Now, if the probability of rain is 30%, what's the probability of no rain? 70. If the probability of doing homework is 40, no homework is 60. Homework is 10, no homework is 90. Every V thing, every one of these has to add up to 100 because it's yes or no. Now, I want to know the probability of him doing homework. So he can do homework here, or he can do homework here. So I have to find the individual probabilities of each branch. So if it rains and he does homework, what am I going to do to these two numbers to get this total probability here? What am I going to do to these? Multiply. So that's going to be 0.12. It's going to rain and he's going to do homework. Whenever it's and, I multiply. So I multiply 0.3 and 0.4, and that gives me 0.12. Now, what about this one? Got to start at the top and come all the way down. So this is going to be 0.7 times 0.1, which is 0.07. So he can do homework on a rainy day or on a sunny day. He can do homework both ways. So what am I going to do with these two answers? Add them. So the answer is 0.19. There's a 19% chance that he will do his homework. So on the individual branches, you're always going to be multiplying. But when you have multiple branches that are contributing to the problem, you're going to add. All right, next, same thing. What's happening in this problem? It's not rain and homework. What is it? So it's noodles or salad? Noodles or salad? So which one's coming first in the diagram? What's going to come right here in the diagram? Noodles and no noodles. And then we're going to have salad or no salad. Salad or no salad. Does anybody have a question about that setup? You got to get the words right in order to get the numbers right. All right, Go ahead and put your numbers in, the ones from the problem that you know. So 80% here, 50% here, and here. What about up here? What am I going to do with that? So they serve noodles once every school week. So what does that mean?
0.2.
0.2. 20% of the time we have noodles. 1/5. 1/5. And remember, with probability, you can put fractions or decimals. I'm using decimals because that's what's in the problem, but fractions are fine. So if that's a 0.2, this is a 0.8. And I want to know the probability that I'll have salad. So that's this branch and this branch. Those are the salad branches. So here we go. Down this branch, all the way down, 0.16. All the way down, 0.40. I got a 56% chance that the cafeteria will serve salad. Okay. Well, there is one more. Would you take a minute and see if you can come up with the answer? So see if you can build your diagram. And then fill in all the numbers and then ultimately answer the question. Okay, Allie, what'd you put here on the first level of your tree?
I'm at 0.70 and 0.30 for soccer and no soccer.
Okay, so soccer and no soccer. And so this must have been lacrosse and no lacrosse?
Yeah.
And then you said this percentage was what? 0.7 and 0.3?
Yeah.
Perfect. I think I agree with that. And then, what'd you put here?
0.62.
Yep. And on the other side, 0.48?
Yeah.
Perfect. Any question about that? Everybody have a setup similar to that? Well, now it's super easy. What's the question? We're going to play lacrosse, so we want this one and this one again. We could just as easily have found the probability of no lacrosse and followed those branches down. But we want lacrosse again, so I'm going to need a calculator here. So 0.7 times 0.62, 0.434, or 144. I got an answer of 0.578. So 57.8% chance that a kid will play lacrosse.
Mrs. Ford?
Yep.
Rory's iPad, he texted me, he said that he's having problems with it right now.
Yeah, I've let him in about 16 times. And he's still technically hooked up, but I don't see him. So thank you for letting me know that.
Yeah.
Okay. All right. Okay, so that's all of that. Now, let's spend a minute or some time here since we have finished the first half of the chapter. We still have half to go. Let's try to recap and pull some things together. So grab your review packet, that big packet. We looked at some of it already. But grab that out and let's look at the thing called Precal A Bus Quiz 9.1, 9.3. It's page 6. So it's page 6 of your review packet. And you're saying, Mrs. Ford, why is it called a bus quiz? Well, in a normal year, we would have taken a field trip. We always take a field trip in Mrs. Ford's pre-calculus classes, but we can't this year because of COVID. But because we can't lose a day of class, we would always have a quiz on the bus on the way to the field trip. And this was our quiz. So let's see how you would do if you were taking this quiz. Okay, so here we go. Number 1. This is review, page 6 of our review packet. Do you have your iPad? Why don't you get it out on school?
I'm not supposed to be taking notes.
Huh?
I'm not supposed to be
Oh,
taking
okay,
notes.
okay. You're just listening? Okay. How many 5-card hands from a standard deck have exactly 1 king and 3 queens? All right, who has a thought? Get us started. What do you think? So 4C1 times 4C3. So 1 king and 3 queens. I like that a lot, but it's not finished. Who can tell me what's missing?
Is it over 52C5?
It would be if it were a probability question. But since it's not a probability, that's a very common mistake, Grace, so I'm glad you brought that up. Never, ever, ever will a question that says how many have an answer that's 0.361, which is what you would get in a probability situation. So no, we don't have a denominator, but Grace, you kind of were, you said 52C5? Yes, it's a 5-card hand. How many do I have? 4. What's the other one going to be?
52C.
No, it won't be 52C1. I have to have, it won't be 48, 44. 44C1. Why is it 44? Because it's not a king and it's not a queen. So how many non-king queen cards are there in the deck? 44. 52 minus the 8 kings and queens. This kind of problem catches people all the time because this isn't specifically mentioned in the problem. You have to pay attention. You want 5 cards. You picked 1 here, you picked 3 here, you gotta pick another one. And the one you pick cannot be a king or queen. Got it? All right. Now our class has 15 boys and 10 girls. And I'm going to pick 3. What is the probability of having exactly 2 boys? Now, this is a probability question. So it is going to be a fraction. It will have a denominator. The denominator of a probability question is always the total. How many total kids are there? Total kids? 25. How many am I picking total? 3. Your denominator is 25C3. Just exactly the same, Grace, as your denominator was going to be 52C5, because there's 52 cards and we're picking 5 of them. This is 25C3. There's 25 kids and I'm picking 3 of them. Now, what kind of kids am I picking? Well, I need exactly 2 boys. So 15C2 will take care of the boys, and 10C1, because if I need 2 boys on a 3-person team, I need a girl. This is just like a card problem. This is done just exactly the way a card problem's done. All right, number 3. What is the probability of guessing exactly 4 correct on a 10-question multiple choice quiz if each question has 4 options? All right, so we have 10 questions and 4 options, and we want to get exactly 4 correct.
Would it be 10C4 times 4C1?
Okay, let's wait a second. I love the 10C4. I'm going to start with that. Because what that's doing is saying there are 10 questions and you are going to pick 4 of them to be correct. This 4 is this 4. Now, do you care which 4 you get correct? No, that's why I'm using a C and not a P. Because I don't care what order they come in, I just want 4 of them to be correct. Okay? Now, the probability of getting it right, of getting a right one, is 1/4. Would you agree with that? And I want to do that 4 times. The probability of not getting it correct is 3/4. And I'm going to do that 6 times because there are 10 questions altogether. This is a binomial probability problem. This is a Pascal triangle type problem because when you sit down to guess, you're going to get it right, you're going to get it wrong. Right? So 1/4 to the 4th, 3/4 to the 6th. We don't care which ones these 1/4ths are. So we're going to pick out 4 of them, 10C4. Those are going to be the 4 that are right. And then all the rest of them are going to be wrong. So then we would multiply all that together. Let's make sure we know how to do that. With fractions, you want to make sure you put them in parentheses. I got 0.145, or actually 0.146. Did I do that right? I'm waiting for somebody to confirm that, please.
Yep.
Okay, super. All right, next, number 4. How many ways can a pitcher and a catcher be chosen from a team of 9 players? Okay, here's my bucket of players. I got 9 of them in here. I'm gonna reach in and grab 2. Is it gonna be 9C2 or 9P2? P, because don't they have different jobs? So the order I pick them matters. So that would just be 9P2. If I were picking 2 kids to stand on the sideline, then it would be 9C2. But if they have different jobs, it's always P. If they have different jobs. How many ways can 7 books be arranged on a shelf if 3 of the books are identical? 7 books on a shelf, 3 are identical. Bingo, right on, Grace, perfect. 7 things on a shelf is going to be 7 factorial, period, forever. If any of them are duplicates, we have to divide by the duplicates factorial. So 7 factorial over 3 factorial. How many ways can the letters of the word field trip be arranged? What are you doing first? I hope you're counting. Yeah, there's 9 letters. So it's just like the books on a shelf. We're going to start with 9 letters. They're going to be 9 factorial. Do any of them repeat? Got 2 I's. Are there any others? I don't think so. Is that it? So that would be 9 factorial over 2 factorial. There are 300 seniors at Cathedral. Of these, 240 take or have taken Precal. Of the Precal students, exactly half say they love vectors, 90 say they love matrices, and 70 say they love both. How many Precal students say they love neither vectors nor matrices? Thoughts?
Are we gonna do a Venn diagram?
Yes! Who said that?
Well, that was me.
Jesus, you are an amazing human being. Thank you. Jesus read this problem and said, oh my gosh, I've got people doing this, people doing this, people doing both. That sounds like a Venn diagram. So here we go. Here's our Venn diagram. And the people like vectors or matrices. So we got vectors and we got matrices, okay? Now, how many students are we actually talking about? Be careful. 240. So there's 240 kids in here because we're only talking about the pre-cal kids. We don't want to talk about anybody else. Of the pre-cal students, half say they love vectors. So 120 kids love vectors. That number does not go in the diagram. That's this whole wall. 90 say they love matrices. And 70 say they love both. Can I put a 70 right there? Now, once I put a 70 in there, then I know this is 20, right? Because the M ball is 90. And this is 50 because the V ball is 120. Now, what does that add up to? So there are 100 kids out here that don't like either one. And that was the question, right? How many don't like either? So that would be 100. Does anybody have a question about that? George, are you there?
Yeah.
Okay, wake up, George. I know this quiz was taken by your sister. I know that because it's.
What'd you do on it?
I remember that. I'm sure, George. But I know that because that's the only year I had 39 kids in a class. Her class was huge. So this was her class. Isn't that interesting, George? It connects us. How many ways can I award 3 identical prizes to my class of 39 kids?
Just use 39C3.
39C3. Why is it a C and not a P? Order doesn't matter because all of the prizes are identical. All right, here we go. There is a 65% chance that Grant will come to Precal on any day. If he comes to class, there's a 74% chance he'll pass the quiz. If he doesn't come to class, da-da-da-da-da-da. Find the probability that Grant will not pass the quiz. Thoughts about this? It's a conditional probability. So that's an easy way to do that is with a tree diagram. Not the only way, but an easy way. So I'm going to build a tree diagram, and he's either going to come to class or he's not going to come to class. Because the question is, pass the quiz or not pass the quiz. Does everybody, like Jesus felt that Venn diagram problem? Are you guys feeling this tree diagram for this problem? Conditional probability. All right, so there's a 65% chance that he'll come to class. So 65, 35. If he comes to class, there's a 74% chance he'll pass the quiz. If he doesn't come to class, there's a 12% chance he'll pass the quiz. This time, we're finding the probability that he won't pass. All right, so here we go. Remember, we multiply on the branch because this is, he comes to class and he fails. So we multiply. 0.65 times 0.26. So 0.169. Then this one is, he doesn't come to class and he fails. So 0.35 times 0.88. And then what do we do with those when we have multiple branches? Add them. So the answer is 0.477. There's a 47.7% chance that he's going to fail. It's not a very happy problem, is it? All right, number 10. How many ways can 4 boys and 3 girls be seated in a row? 7 factorial. Kids, do we care whether they're boys or girls? Does it matter? Are there any conditions in the problem? No, we got 7 people. They can be seated 7 factorial ways. Don't you dare do something like this and say, but Mrs. Ford, there's 4 boys and there's 3 girls. Yes, but they are not identical. People cannot be identical. So we don't divide by anything. It's just 7 factorial. On the field trip, we normally plant some trees. So number 11, how many ways can you arrange 15 students around the tree being planted? 14 factorial. Because when we do it in a circle, it is 1 less factorial. And finally, how many ways can you seat 3 algebra and 6 pre-cal students in a row if the algebra students must sit together? So we have 3 algebra and 6 pre-cal, and we're going to seat them in a row, and these guys got to sit together.
You don't know?
That's exactly right. It's exactly right. It doesn't matter one bit the way we did it before I started with 7 factorial, because like in this problem, I had 7 people that I was arranging, and 7 people can be arranged 7 factorial ways. Here, I don't really have 9 people that I'm arranging because these are tied together. So it's like they're all tied together. They can't be separated. So you have 6 people and then a bundle of people. So you're arranging 7 things. 6 plus 1, 7 things. But when you tied those guys together, that can be done 3 factorial ways. Those 3 within their bundle can be arranged 3 factorial ways. Okay, so whatever that is, that's the answer to the question. Very, very, very good. All right, so of those problems, we did a little bit of everything there. That's a good review. We have time to do 1 or 2 more. Who has a question about, tell me which problem was a little confusing to you, and we'll do another one like it.
So I guess with the difference between problems 10 and 12, I still don't understand like why the 3 algebra students differ from like the 4 boys, because I can't like really tell like how like that makes them a bundle, the 3 algebra students.
Did you read question 12 all the way through to the end? What does it say at the end of the problem?
Yeah. They must be seated together.
Okay, does problem 10 say that the boys have to be seated together?
No.
There you go. There's your difference.
Okay. Thank you.
Mm-hmm. Solar? You understand everything. All right, anybody have a question? At some point, we gotta have a quiz over all this, but it won't be till we come back, but we're moving on in the next class, so this is your chance. Ask away.
For the first one, where you have to pick a 5-card hand,
Uh-huh.
what if it's the at least 1 king and at least 3 queens? Would you do the same thing, except at the end it would be 52C1 instead of the 44C1?
No. That would be a much more complicated problem. You would have to consider each case individually. So if you're picking a 5-card hand and you have to have at least 1 king and at least 3 kings, or queens, whatever it is. I don't know, am I doing this wrong? 1 king, 3 queens, that's right. Okay, so one option, the one that we did, was 1 king, 3 queens, 1 other card. All right, so we did that one. But with the scenario putting in at least, we could have 2 kings and 3 queens. So we'd have to do that probability. Or we could have 1 queen and 4 kings. So we would have to do that probability. So we would need to do all of those individually. This one we already did. But we would need to do these 2 individually and then add them all up.
Okay.
Okay. Anybody else have a question? All right, you gotta hang on for the blessing, guys. It's the last period of the day, so hang on. I'm gonna take attendance and y'all better be there. Yesterday, we had some goofballs leave, not good. All right, I'm gonna call your name. Say here. Reed.
Here.
Nicholas.
Here.
Michael.
Here.
Jesus.
Here.
Rory. Did Rory ever get back in? No, he didn't. Okay. Caleb. Caleb, I haven't seen you all period. Are you sleeping? David.
Here.
Oscar.
Here.
Jacob.
Here.
Declan.
Here.
Caden.
Here.
Ellie.
Here.
Danica.
Here.
George.
Here.
Hector.
Here.
Jessica. I know you've been having trouble. You're here? Okay, good.
Yeah.
Brenda.
Here.
Josh.
Here.
Grace.
Here.
Straley, yeah. Haley.
Here.
Andrew.
Here.
All right, let's hang on for the blessing, guys. Nobody leaves early. Please hang on. Caleb, one more chance. Are you here? Caleb. Sleeping.
I think my chapter 7 test.
When we're done here.
Oh,
You're supposed to still be in class. I do not know what you're doing wandering about.
I don't know.
Just sit down, listen to, wait for
Sorry.
prayer. So next time, guys, have your 9.4 notes ready, because we're going to start with that next time we're together, okay? Oh, shoot, I can turn off. Don't need to be video.